Pa- uh, that means how to tell I'm not getting that.
You have exam tomorrow, you kept leave today, you have prepared. Still no answer, Gautam. So if you apply pressure at one point, the pressure is transmitted equally in all the directions. That is what Pascal's law. Okay. So pressure applied at one point is transmitted equally in all directions. In all directions. Clear? Pressure applied at one point will be transmitted equally in all directions. That is the meaning of Pascal's law. That means if you take a container, if you keep 4 holes here, and if you cover them with some pistons, okay, so let this be first one, second one, third one, fourth one. So if I apply pressure at first point, if it is P1, what will be the pressure at second point, third point and fourth point? There also it will be P1, P1, P1. Getting my point?
Yeah, ma'am.
And what is the condition? First one, second one, third one, fourth, all should have the same area. Then only pressure will be same.
Yes, ma'am.
Getting my point?
Yes, ma'am.
Pressure applied at one point, it is equally transmitted in all the directions. Okay. Now we'll go for today's topic. Today we'll go for hydraulic press, mechanical advantage, all those things. Okay. So first we'll see what is mechanical advantage. Today's first topic. Mechanical advantage. It is denoted as M dot A. Okay. So what is this mechanical advantage? Mechanical in the sense which is, undergoing motion, like related to missions and all. Okay. Advantage, that means when you take the missions, when we apply the Pascal's law, we will be having an advantage that we apply less force but we get more force at the other side. We apply very less force but more force can be obtained at the other side. That is the meaning of mechanical advantage. What we do here is, Gautam, we just take two containers. One is having small area of cross section and we take the other side a bigger container. Am I audible?
Yeah, ma'am.
Okay, so this is one side, this is two side. Okay, first side and second side. So what we are going to do is we are just going to fill it with water. So till there is equal level of water in both the beakers, the water movement will start from one beaker to the other beaker. Okay, now here we just connect them with the pistons. Okay, now this is piston 1 on side 1, this is piston 2 on side 2. Now can you tell me which piston is having more area?
Piston 2, ma'am.
So bigger area, no? So I'll just take its area symbol as capital A because bigger. Now the area of the first piston, I'll take it as small a because area is small. Is this clear?
Yes, ma'am.
Okay. Now I'll assume one thing. Let me apply some force F on the first piston. So what happens now when force is applied on this particular area? What happens? Pressure is created, right? Now this pressure is equally transmitted in all the directions. Now what happens? This pressure is applied on the piston 2 now. Getting my point, Gautam?
Yes, ma'am.
We have applied force on piston 1 on this area of the piston. This is having area small a. So force F by A is nothing but pressure. So some pressure is acting on the first side. Now this pressure, according to Pascal's law, it will be transmitted to the beaker 2 also. So water is applying the pressure now from downward direction. So it is pushing the piston 2 in upward direction now. So what happens to the piston 2 now? It moves up. Getting my point?
Yes, ma'am.
When we have applied force on the piston 1, piston 1 was moving in which direction? It moves down. And here second side piston is moving up. Is this clear?
Yes, ma'am.
Okay, now with how much force it is moving up, let us take it as F2.
Ma'am, both beakers are filled with equal amount of water, right, ma'am? Then why will they move?
It's not like equal amount of water. If you take the beaker too, it's bigger in size, so it will be having more amount of water. More
Oh,
is the
okay.
area of cross section. Bigger container means larger amount of water, right?
Yes, yes, ma'am.
It is equal level of water. That means height of the water will be same.
Okay,
2
ma'am.
centimeters height, 2 centimeters height, or 5 centimeters height, 5 centimeters height. Level of water will be same, but not the amount of water. Okay.
Okay, okay, ma'am.
So what are we doing? We are pressing on the first side. So when you press the water, what happens? That pressure is transmitted to the adjacent water molecules. So those water molecules on the second side, they are connected to piston. So piston also will feel that pressure. Or else simple Gautam, వాటర్ బాటిల్ ఉందా, వాటర్ బాటిల్ మూత లూజ్గా కనెక్ట్ చేసి పెట్టి కింద ప్రెస్ చేయి, చేస్తే ఏమవుతుంది?
Ma'am, it
The
water fills up.
the lid will blow away, right?
Yeah, ma'am.
Lid will blow. Are you literally applying the pressure on the lid? No,
No, ma'am.
you are applying pressure at the bottom of the bottle. But why the lid is falling away? Because the pressure which you have applied at the bottom of the bottle, according to Pascal's law, it is transmitted by the water molecules to the lid of the bottle. గెటింగ్ మై
Yes.
పాయింట్. మనం కింద అప్లై చేసినాం ప్రెషర్, కానీ లిడ్ ఎందుకు పోయి పడిపోయింది? ప్రెషర్ మనం బాటిల్ మీద అప్లై చేస్తే, బాటిల్ లోపల ఉన్న వాటర్ మీద అప్లై చేస్తే, ఆ వాటర్ ఒక వాటర్ నుంచి ఇంకొక వాటర్కి స్ప్రెడ్ అయ్యి లిడ్ మీద ప్రెషర్ పడి లిడ్ బయటకు వచ్చేస్తుంది.
Yes, ma'am.
What is the principle here? It's nothing but Pascal's law. So
Yes, ma'am.
same concept here. You are applying pressure on piston 1. You are pushing the piston 1 in downward direction. So when you press the piston, below the piston, what do we have? We have the liquid water. So water gets that pressure and it will transfer that pressure to whom? On the other side, piston 2. So
Yes, ma'am.
piston 2 will rise away, it will move up.
Yes, ma'am.
Okay, now if you see the area, this is the area that is considered in the first case, small a. But if you see the second side, area is more, right? So obviously what will be the force here? It will be more or it will be less?
Force will be more.
Force will be more. So I can say that F2 side pressure, F2 will be more compared to F1, because A2 is more than A1. Okay, what is the formula for pressure, Gautam? It is F by A, right? From
Yeah,
this
ma'am.
formula, what will be the formula for F? It is pressure into A.
Yes,
Okay,
ma'am.
so if you see, force is depending on two factors. Force is directly proportional to pressure, also force is directly proportional to area. According to Pascal's law, though there is equal pressure, area is not same here, right?
Yes, ma'am.
Throughout the setup, throughout the liquid, though pressure is same according to Pascal's law, area is not same. First side area is less, second side area is more. So there is a difference in area. Pressure is constant according to Pascal's law, equal pressure is transmitted. But what about area? Area is not constant. So will the force be constant now? Force also depends on the area. Where area is more, force will be more. Getting
Yes.
my point, Gautam?
Yes, ma'am.
పాస్కల్స్ లా ప్రకారం ప్రెషర్ ఈక్వల్గా ట్రాన్స్మిట్ అవుతుంది. ప్రెషర్ త్రూ అవుట్ ద సెటప్ సేమ్ ఉంది, కానీ ఏరియా సేమ్ ఉందా? లేదు. ఫోర్స్ ఈజ్ ఆల్సో డిపెండింగ్ ఆన్ ఏరియా, రైట్?
Yes, ma'am.
డైరెక్ట్లీ ప్రపోర్షనల్. సో ఏరియా ఎక్కువ ఉంటే ఫోర్స్ ఎక్కువ అయిపోతుంది, ప్రెషర్ కాదు, ఫోర్స్ ఎక్కువ అవుతుంది.
Yes, ma'am.
ఓకే, సో వాట్ వీ విల్ డూ ఈస్, వీ విల్ టేక్ ఎ మ్యాథమెటికల్. ఈజ్ దిస్ కాన్సెప్ట్ క్లియర్?
Yes, ma'am.
దీన్నే మెకానికల్ అడ్వాంటేజ్ అంటాం. వాట్ ఈజ్ మెకానికల్ అడ్వాంటేజ్? గెటింగ్ గ్రేటర్ ఫోర్స్ on side 2 by applying lesser force on side 1. మనం తక్కువ ఫోర్స్ అప్లై చేస్తున్నాం, బట్ వీఆర్ గెటింగ్ ఏ గ్రేటర్ ఫోర్స్. ఇట్స్ అన్ అడ్వాంటేజ్ ఫర్ అస్. మనం కష్టపడి ఎక్కువ ఫోర్స్ అప్లై చేయాల్సిన అవసరం లేదు. కొంచెం ఫోర్స్ అప్లై చేసినా ది అదర్ సైడ్ వీ గెట్ ఎ గ్రేటర్ అమౌంట్ ఆఫ్ ఫోర్స్. So
Yes, ma'am.
so that benefit is called mechanical advantage.
Yes, ma'am.
Okay, so we have a formula for mechanical advantage. You have to remember that. So side 1 and side 2. Okay, so side 1, what is the force applied? Let it be F1, but we call it as here effort, E. Okay, instead of taking the symbol as F1, now we will take E. E means effort, ante మనం ఎంత force apply చేసినామో that is called effort. The other side, side 2, force is F2, but here we take it as load, L. F1 in a simple way, it's nothing but effort. F2 is nothing but load. Okay,
Okay.
now side 1, what was the area? It is small a. And side 2, what is the area? It is capital A. Now what is the mechanical advantages? Mechanical advantage is equals to, it has different formulas. First formula is load by effort. Second formula is bigger area by smaller area. Now when you take the piston, this is how piston will be, right? If you see the base of the piston, it will be circular in shape. So
Yes, ma'am.
what is the area of the circle, Gautam? It is nothing but pi r square, right?
Yes, ma'am.
So if you take bigger piston, where we are considering all capital letters as a symbol, so I'll take it as pi capital R square. Now
Yes, ma'am.
small area, I'll just take it as small r square, pi r square. Capital A area is pi r square. Small piston area is pi small r square. Is this clear?
Ma'am, can you explain it, ma'am?
We have piston on side 1, also we have piston on side 2, right?
Yes, ma'am.
Side 1 piston is very small in area. So if you take area of that smaller piston, what is the formula? Pi r square.
Yes, ma'am.
As you are using small letter, lowercase letter for area, for radius also you have to use lowercase letter r.
Okay, ma'am.
Now side 2, we have the piston which is bigger in size. So its area is also more. We have considered capital A as its symbol. So
Yes,
when
ma'am.
you take the area of that bigger piston, pi r square, but here we are using capital R as a symbol.
Yes, ma'am.
Capital A means capital R, small a means small r. Area is pi r square. Why? Because area of a circle is pi r square, no?
Yes, yes, ma'am.
Clear? Now pi cancel. So what will you get? You will get r square by r square. So what is the formula for mechanical advantage? First formula, load by effort. Second formula, bigger area by smaller area. Third formula, bigger r square by small r square.
Yes,
These
ma'am.
are the three formulas for mechanical advantage. Important.
Yes, ma'am.
You need to remember. Important. Any
Okay,
doubt?
ma'am. No, ma'am.
Okay. Now we'll see the uses of this mechanical advantage. One of the best applications of this mechanical advantage is hydraulic press. What is the use of this mechanical advantage is hydraulic press.
Yes.
Hydraulic means water. Press means pressing. Hydraulic means we use water, liquid in the machine. Press means here pressing. So what do we do is we just take the help of mechanical advantage, Gautam. I'll just show you the figure. Wait a minute. Mm. You see this. What are we doing here? So if you see the left side, it is having smaller piston. Right side, it is having bigger piston. Now this bigger piston is connected to some floor on which some car is kept, right? So
Yes, ma'am.
if you see the repair shops and all, they lift the car because they have to work, they have to do some, repairs and all in the car. So what do? They lift the car. Now imagine, can a human being can lift the car?
No, ma'am.
No. So what do? We take the application of this mechanical advantage. The others, we have this setup in the, automobile shops. One side they will apply less force. The other side, car side, they will get more force. Why? Because area is more, so force also increases.
Yes,
So
ma'am.
this is benefit for us, right? Instead of the person lifting the car, better you apply some less force on one side and you are getting, more amount of force on the other side, and that force you can use for lifting the car.
Ma'am, in that fluid place,
We use water.
pressure is traveled, right? No,
Mm-hmm.
no, in that fluid, in that water, the pressure exerted by us is traveled.
Yeah, exactly. According to Pascal's law, in this fluid, pressure exerted on first side is transmitted equally in all the directions.
Okay, ma'am.
Okay. So this is hydraulic press, but what do we do is we use it for different purposes, Gautam. Okay. So so this is the first piston. This is the second piston. So piston one side we apply effort. Effort means the force which we are applying. Piston two side, the force that we receive is called what? Load, L.
Load,
Okay.
load, ma'am.
Now what do we do? First thing is we use it in servicing automobiles. That means to repair cars and all, we use it. Okay. For what reason we use it? To lift the vehicles, we use this. Okay. So on the piston side too, we just connect this to a horizontal floor, and on this we will keep the car. Okay. And second thing, for pressing the cotton bales or straws, what do? We use this. So what do they do there is, they just keep the cotton bags here. I'll just show you the figure. Can you see this figure? See the pistons two side. This is the floor. On the piston floor, they have made some connections here,
Yes, ma'am.
and they have created some gap. You can see it here. So in this gap, can you see this part which I am showing with the cursor?
1 minute. No, ma'am. Yes, ma'am. Yes, ma'am.
So can you see this part?
Yes, ma'am. Yes, ma'am. That red
So
color.
here they keep cotton, or they can keep straws, or they can keep metals. What do they do is, Gautam, same principle, mechanical advantage. They apply force F1 on first side. They get more force F2 on the other side, and this force is used for pressing the cotton. When you see cotton is porous in nature, right? It has so much air trapped in it. So how we can press with normal hands, with human beings effort? It is not possible. So what do they do is they use this hydraulic press, and they press the cotton. Straws also, metals also. When you take the metals, they may just make into flat sheets, right? It's a property called malleability. Metals can be
Malleable.
converted,
Yes.
yeah, into sheets. So how is that achieved? Such a flat sheets, how is it possible? With the help of this hydraulic press. So this is the setup. If you use it for pressing the cotton, it's used for compressing the cotton bales. If you use straws, it is used for compressing the straw. If you use metals, it is used for malleability of metals. Okay. Sometimes what do they do is, here they will keep oil seeds. They'll keep oil seeds, and here to the lower part, what do they do is they keep some connections, and they'll extract the oil here. They will press the oil seeds. Oil will be collected later into some collecting flask. For pressing the oil seeds also, they use this hydraulic pressure.
Yes, ma'am.
Okay. And sometimes what happens is, same diagram, but what do they do is, if you use metal sheets here, if you use metal sheets and if you want to make holes into that, what do they do is, so to the piston here they keep sharp nails here. They keep sharp nails, or else they can you can keep the sharp iron nails on the top also, wherever we want, any one side. Okay. Sometimes two cases also, they'll keep iron nails. Now when you press, what happens? Iron nails will keep the holes into the metal sheets.
Yes, ma'am.
Got my point?
Yes, ma'am.
Okay. So this is how we use the hydraulic press. Now tell me, repeat all the points. It is used for servicing the automobiles, for pressing the cotton bales and straws, and to get oil from oil seeds. And what else? To make holes into metal sheets.
Ma'am, why should we make holes in metal?
Why should we make holes in metal sheets if it is required? Like if you take machinery parts, One metal is connected to the another metal. How are they connected? Keeping the holes and keeping the nails into it.
Okay, ma'am. Okay, ma'am.
Okay. Now, you can't use all the sheets every time, right?
Yes, ma'am. Yes, ma'am.
Okay. And what else, like if you want to give any specific shape to the sheets also, they will use it. Okay.
Okay, ma'am.
So clear with this mechanical advantage, hydraulic press, and they are working on which principle? They are working on Pascal's law principle.
Pascal's law. Yes, ma'am.
Any doubt so far?
No doubt, ma'am.
Okay. Now we will go for Archimedes principle. This is also very important. But before going for Archimedes principle, let me give you some idea. Okay, observe this figure, Gautam. Observe this figure. So what are we seeing here? There is a spring balance which is used for measuring the weight. Weight
Yes, ma'am.
means m into g. Okay. So if you see here, there is a stone which is attached. So let this stone weight, when you measure it outside, no, and that means before dipping into water, it was 6 kg. Okay.
Yes, ma'am.
Now let us take the same stone and let us keep it into a beaker containing water. Okay. Then what was the weight that was absorbed in the spring balance? When it is inside the water, we have absorbed how much weight? 4 kg weight. What happened to the remaining 2 kg weight? Why are we not seeing that 2 kg weight? Why does it disappear? Because Archimedes said that when you take any bodies, when they are immersed into the fluids, they experience some upward force.
Upthrust, ma'am.
Yeah, upward perpendicular force. What do we call perpendicular force? It is called thrust. And upward means upthrust. So they experience some upthrust force, and this is also called buoyant force. Upthrust is also called what? Buoyant force. So
Yes,
you
ma'am.
also
Beyond.
we generally feel it, no, Gautam, like whenever you go to swimming pool or whenever you go to, when we get into water bodies, we can easily move our body. We don't feel weight. We just feel weightless. Why is it
Yes,
so? Because of this buoyant force, because of this upthrust.
yes, ma'am.
The same thing is called Archimedes principle. Archimedes is a name of a person. So one day what he was doing is he went outside, and after returning, he was just doing something. He suddenly jumped into his bathtub, and he has seen, he just felt weightlessness, and he got this idea when he was doing bath. Okay, so whenever we are in water, we lose some weight. This is because of the buoyant force, and that is how the Archimedes principle came out.
He shouted as Eureka.
Yeah. Okay, yeah, you know that story, right? Now,
Yeah, ma'am.
so outside it was 6 kg, inside it was 4 kg, so remaining 2 kg weight was disappeared, right? Isn't it? So
Yes,
this
ma'am.
2 kg weight is nothing but what? Upthrust. That means how much weight of the body is disappearing, that will be equal to upthrust.
Yes, ma'am. Means by and force. Yes, ma'am.
Yeah. So I can say upthrust is nothing but the
Weight
weight
of weight of
body,
fluid is placed, ma'am.
yeah, weight of the body disappeared, first of all, first formula. Okay. How much that was? That was 2 kg into g. Okay. Now, so if you see, this was also equal to what? If you keep the body inside the liquid, some amount of the fluid is occupied by this block, right? Some amount of the fluid has been displaced out. So if you
Yes,
see
ma'am.
the weight of that fluid displaced, that is also 2 kg.
Yes, ma'am.
That means upthrust is equals to weight of the body that has disappeared, and this is also equal to weight of the fluid displaced.
Yes, ma'am.
Getting my point?
Yes, ma'am.
Okay. So we'll just get back.
Ma'am, how to measure, ma'am? It flows that water displays will flow through all over the bucket, right, ma'am? Then how to measure each?
What we have to do is we should not fill the bucket completely. We should not fill it till its brim. We have to leave some space. As you can see in the figure, we have to keep some connecting side laterally. We have to keep some connecting pipe. You don't fill it completely to the top. You have to leave some space.
Okay, ma'am.
Okay, if you fill it till the brim, what happens? It overflows. We cannot collect it. We
Yes,
should not
ma'am.
fill it completely. Okay, so what is upthrust or buoyant force? It is denoted as FB, buoyant force. What is this buoyant force, Gautam? It's nothing but the thrust acting in upward direction. The thrust acting on a body in upward direction. And when do we get this buoyant force? When the body is in air or when the body is in liquid?
In liquid, ma'am.
When it is in liquid. So let us take a container, let us fill it partially with some liquid, okay, and let us immerse a body into it. Then what happens? The
Ma'am, the
body,
body should be wholly or partially.
it can be any case, it can be completely or it can be partial. In both the cases, upthrust will be present.
Okay, ma'am.
Okay, so weight of the body is acting downwards, that is m into g. Now upward, what is acting? Buoyant force, which is also called upthrust.
Beyond force, yes, ma'am.
Yeah, so this upthrust is equals to what? Weight of the
Of fluid,
body disappear.
yes, ma'am.
Like outside some weight was there, inside some weight is less, so how much of weight of the body disappeared, that is upthrust. And this is also equal to what? Weight of the fluid displaced by the body.
Yes, ma'am.
Weight of the fluid displaced by the body. Clear with this, Gautam?
Yes, ma'am.
So the same thing is nothing but Archimedes principle, but extra we consider volume also here. See, you can relate these to know this is first formula, this is second formula. In both the formulas, LHS part is same, that is upthrust and upthrust, right?
Yes, ma'am.
So I can equate the RHS now. Weight of the body disappeared is equal to weight of the fluid displaced by the body. Can I do that because LHS is same, no?
Yes, ma'am.
Okay, so from this I can say weight of the body disappeared is equals to weight of the fluid displaced. Okay, now I can also say volume of the body immersed in the fluid will be equal to volume of the fluid displaced. Any doubt in this? How much volume of the body is present in the liquid, the same volume of the fluid will be coming out.
Yes, ma'am.
If I suppose the body present inside the fluid is having volume of 5 meter cube, then how much fluid will be coming out? 5 meter cube only. How much
Yes,
volume of the body is present inside, the same volume of the liquid will be displaced.
yes, ma'am.
Okay, so now we'll go for Archimedes principle. Any doubt in this, Gautam?
No, no, no,
Okay,
no.
I will not be able to complete the whole syllabus, Gautam. You have to read, okay?
Okay, okay,
Because I cannot rush, okay? Whatever I want to teach, I want to make it clear, okay? So what
okay.
is Archimedes principle? When a body is partially or completely kept in a fluid, immersed means kept, immersed in a fluid, then what happens? Then it experiences what?
Upward thrust, ma'am.
Yeah, then it experiences a force in upward direction, which is called upthrust. And this upthrust will be equal to what?
Weight of fluid displaced.
Yeah, which is equal to, I told you that weight of the body disappeared, right?
Yes, ma'am.
That is also called apparent loss in weight, which is equal to, okay, fine, I'll write whatever you know, weight of the fluid displaced, right?
Yes, ma'am.
Now I told you outside 6 kg, inside 4 kg, so remaining 2 kg is disappeared, right?
Yes, ma'am.
So this weight disappeared is also called apparent loss in weight.
Yes, ma'am.
apparent loss in weight. What does it mean? The weight which is present outside the fluid minus the weight which is present inside the fluid.
Yes, ma'am.
Okay, so I can say which is equal to weight of the fluid displaced. Also, I can say upthrust is equals to apparent loss in weight. Different
Yes,
different terminologies, but all mean the same, Gautam. Okay.
yes, ma'am.
Now, when you take the applications of Archimedes principle, like as I told you, whenever we go into swimming pools or whenever we get into some water bodies, we feel our weight is lost. So it's because of what? Buoyant force. Or else we
Yes,
can do one thing, we can be inside the water body and we can take a huge stone outside the body, outside the fluid, and take the same fluid, take the same stone when you are inside the fluid. So in which case you feel less weight.
ma'am. When we are under and we take heavy.
Yeah, so the stone weight is same, but when you are in air, you feel very much heavy weight of the stone. But when you hold the same stone in the water, what happens? We feel less weight because that water is exerting upthrust. So we feel less weight of the stone.
Yes, ma'am.
Okay. So certain important things related to Archimedes principle. So first one, let it be you who is holding the stone. Let us assume that it is having 5 kg. So what will be its weight? 5 into g, 5g, m into g, right? This is
Yes,
the
ma'am. Yes.
weight. Now let us take the water. Now this is same you, Gautam. You are inside the water now and you are holding the same 5 kg stone. But how much weight do you feel now? Maybe let me assume that you are feeling only 3g weight. That means remaining 2 kg weight is lost. It's because of what? Because here upthrust is acting. And how much is the upthrust? That
2
is
kg.
2 kg is mass, m into g. 2 kg into acceleration due to gravity, 2g.
Ma'am, 2 kg, right, ma'am?
Kg is what? It's nothing but only mass. Weight or
Yes, ma'am.
upthrust are nothing but forces. No, force formula is what? M into A. Or if you
Yes,
take
ma'am.
weight, M into G. Mass is 5 kg. If you take force, you also have to consider acceleration, right?
Okay, okay, ma'am.
So 2 into G. So outside it was 5g, inside it was 3g. That means remaining 2g is the value of upthrust. Buoyant force is acting. Okay.
Yes, ma'am.
Weight was acting downwards, buoyant force is acting upwards. Clear with first case?
Yes, ma'am.
Now second case. So let me take, let this be fresh water and let this be salt water. Now, when you take salts and all, yesterday you asked me one question, ma'am, like what happens if we jump from river to ocean? I told you ocean is having so many salts, so its density will be more. So pressure
Yes, ma'am.
acting will be more. So if you take brine solution beta, brine solution density is more.
Ma'am, brine
Brine solution means diluted salt water.
dilute salt. Okay, ma'am.
Brine solution means,
More content of water.
yeah, more content of water. Diluted salt solution. NaCl, you know NaCl, right? Common salt. So
Yeah, ma'am.
diluted NaCl solution is called brine
Sodium
solution. Okay.
chloride.
Yeah. So salt water is having what? More density. So more density in the sense more pressure. So I'll just mention it here. Salt water will give more pressure means more upthrust because density is more. If you take fresh water, less pressure, so less upthrust. Okay.
Yes, ma'am.
So let me take ice cube in both the cases. So if you take the first case where there is less buoyant force, so what happens to the ice cube? It will be more immersed into the liquid and less outside. But if you take the same ice cube into salt water where there is more upthrust, what happens? Majority of the ice will be outside and very few portion of the ice will be inside.
Ma'am, means how can you say that in salt water more upthrust is there and
More
in
upthrust. Okay. Salt water. Salts are present. So what happens to density?
increases?
Density increases. Yesterday I told you, right? Liquid pressure. Pressure exerted by liquids is depth into density into acceleration due to gravity. So here,
HOG.
yeah, density is increasing. So pressure in liquids is increasing. So what is the formula for force? Pressure into area. So pressure is increasing. So force is also increasing.
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. So why do we see more volume of the ice cube outside in the case of salt water? Because from downward direction, what is applying here? Buoyant force is applied. Buoyant force is in upward direction and this force is more. So it will try to push the body outside more.
Yes, ma'am.
Clear, Gautam?
Yes, ma'am.
ఫ్రెష్ వాటర్లో డెన్సిటీ తక్కువ, సో ఫోర్స్ తక్కువ, కాబట్టి అప్వర్డ్ దాన్ని పుష్ చేసే ఫోర్స్ తక్కువ ఉంటుంది. సాల్ట్ వాటర్లో డెన్సిటీ ఎక్కువ కాబట్టి ఫోర్స్ ఎక్కువ కాబట్టి ఎక్కువ పార్ట్ ఆఫ్ ద బాడీ బయటికి పుష్ చేస్తుంది అనమాట. కాబట్టి మనకు మెజారిటీ ఆఫ్ ద బాడీ అపియర్స్ అవుట్ సైడ్ అండ్ వెరీ లిటిల్ పోర్షన్ ఆఫ్ ద బాడీ విల్ బీ ఇన్సైడ్.
Yes, ma'am.
ఈస్ దిస్ క్లియర్?
Yeah, ma'am.
Same thing, let it be stone. You in your textbook it was given about fish. Fish in water weight will be less, fish in air weight will be more. It's the same case like a stone. Let it be fish or let it be human being, let it be stone, whatever it is, in the air it will be more weight, in the fluid it will be less weight. Clear?
Yes, ma'am.
Okay. So due to this upthrust, don't you think the body is floating? Maybe,
Yeah.
maybe partially or maybe completely. It depends on the value of the upthrust, but there is a possibility that body can float, right?
Yes, ma'am.
So what do we call this? This is called flotation. Flotation means floating of the body.
Ma'am, if buoyant force is less means
If buoyant force is less, body will sink.
if it is equal to the if it is equal.
We will discuss. We'll discuss all those cases now. Okay.
Okay, ma'am.
Okay. So when you take flotation, it's related to floating of the bodies. Like it will help you when body will sink, when body will float, when body will be partially inside, completely inside. All those cases we will study it now. But before that, let us take a body. Its weight will be acting downward, right?
Mg. Yes, ma'am.
Yeah, from a center point called center of gravity. This is called C. What is C? Center of
Center.
What is this center of gravity? It is the point at which the whole weight of the body acts. Point at which the whole weight of the body acts.
Ma'am, can you tell what is center of gravity?
See, Gautam, like you have heard about falling tower of Pisa, right? Pisa or Isa, something. Leaning
Yeah,
tower of
Giza. Yes.
Pisa, sorry. Leaning tower of Pisa. So it was leaning, but still it is not falling down. Why is it so?
Because
Because
it's center.
because its whole weight is not acting at the top or not acting at the bottom. It is acting at the center of that pizza,
Yeah, ma'am.
center of that leaning tower. That's why it is not at falling down.
Yeah,
ఇప్పుడు
ma'am.
మన బాడీ తీసుకున్నా కూడా మన బాడీ వెయిట్ మొత్తము ప్రతి పార్ట్ మీద ఉండదు, ఏదో ఒక సెంటర్ పాయింట్ మీద యాక్ట్ అవుతుంటుంది. Even
Yes,
if
ma'am.
you take the gymnastic people, circus people, how do they balance their bodies? Because they try to balance their center of gravity. The whole body weight acts as a center point, so they try to focus only on that center point. Like people will be walking on the rope in circus.
Yeah, ma'am.
Like how can they manage? They manage that center of gravity. We feel like our whole body weight acts on the legs, but it is false. మొత్తం లెగ్స్ మీద పడుతుంది బాడీ వెయిట్ అనుకుంటాం, అది తప్పు. Okay, at different positions there will be different points where our whole body weight will be acting, and that point where the body weight acts is called center of gravity.
Yeah, ma'am.
Okay, so similarly when you take beyond force, the force will not act at all the points, it will act at some center point, that is called what? Center of buoyancy. The point at which the buoyant force acts on the body. clear, Gautam? So center of gravity is denoted by capital C, center of buoyancy is denoted by capital B. Any doubt in this?
Okay, ma'am. No, no doubt, ma'am.
ఏ పాయింట్ దగ్గర అయితే మొత్తం బాడీ వెయిట్ పడుతుందో ఆ పాయింట్ని సెంటర్ ఆఫ్ గ్రావిటీ అంటాం. The point at which the whole weight of the body is acting.
Yes, ma'am.
Similarly, the point at which the buoyant force is acting, that is called center of buoyancy.
Yes, ma'am.
Okay, so if I take an upward force, which is buoyant force, it will be acting at some center point, let it be B, center of buoyancy. Okay,
Yes, ma'am.
is this clear?
Yes, ma'am.
Now we will take three cases.
Ma'am, but there water is not.
There,
Water is not there.
yeah, we have to fill with liquid. Okay, we have
Oh,
to
oh,
fill with liquid. Now there are three cases, Gautam. Case 1, case 2, and case 3. So what is case 1 is, let us assume that the weight of the body acting downward is more than the buoyant force acting in upward direction.
ma'am, can you repeat, ma'am? Weight
Weight,
is?
weight, weight of the body is acting downward, right?
Yes,
And
ma'am.
buoyant force will be in upward direction, right?
Yes, ma'am.
Let us assume that weight is
Okay, ma'am. Then, yes, ma'am.
more weight of the body and less buoyant force. Then what happens to the position of the body? More weight is there, so weight is dominating, so body will move downward and it will sink into the liquid.
Yes, ma'am. It
So what
sinks.
will be the position of the body? It will completely settle down at the bottom of the beaker.
Yes, ma'am.
So this is the weight and this is the buoyant force, and the same point is for center of gravity and center of buoyancy. Both will be at the same point. You may get it out, ma'am, why both are at same point? Always they will be at the same point. Enduku ante weight is counterbalanced by the buoyant force. So where weight is present, there buoyant force will be acting.
Yes, ma'am.
So weight is acting at center of gravity, so buoyant force also will act at that point. So center of buoyancy is also at the same point. Always you take any case, case 1, case 2, case 3, whichever the case you take, always center of gravity point, center of buoyancy point will coincide. That means they
Okay.
will be always at same position. Is this clear? So what
Yes, ma'am.
happens to body position? Body is sinking here, body will sink. And when you compare the density of the body here, it is more than the density of the fluid. Can I say when density is more, it will sink?
Yeah, ma'am.
So when upthrust is less, body will sink. When weight is more, body will sink. When density of body is more, body will sink. However they ask, same answer. More weight, less buoyant force, more density of the body, less density of the fluid. Whatever they say, body will sink.
Okay, ma'am.
Any doubt in this?
No doubt, ma'am.
Okay. Now let us take weight of the body is exactly equal to upthrust. That means equal weight and equal buoyant force. Then what happens to the body? Body will float. Okay. And how the body will float is, this is the surface of the fluid, right? So it
Yes,
will
ma'am.
touch to the surface of the fluid and this is how it will float. It is not complete, it is not completely sinking down. It is floating such a way that it is attaching to the surface of the fluid.
Ma'am, then it can rise also.
When it will rise? If upthrust is more.
Yes, ma'am.
When upthrust is more, it will rise. Here
Yes.
is it is equal to weight, no? So this is the weight of the body acting downward. This is buoyant force acting upward, and both are equal. So it will not sink completely, it will not rise completely. It will just stick to the surface of the fluid and it will partially float.
Yes, ma'am.
Okay, so I can say here body sinking is completely immersed and it is at the bottom of the beaker. Here also body is completely immersed Completely inside the water, but is it at the bottom?
No, ma'am. It is like middle.
Not even at the middle, it is sticking to the surface.
Okay, ma'am.
So not at bottom. Clear? Middle means what? Not bottom, not to the surface, at the center. It is not at the center, no, it is touching to the surface of the fluid.
Okay, ma'am. Yes,
So
ma'am.
here also center of gravity C, buoyancy, center of buoyancy B, both will coincide. Is this point clear, Gautam?
Yeah, ma'am.
So here density of the body will be equal to what? Density of the fluid.
Yes, ma'am.
One more important. Now let us take case 3. This time we will take less weight for the body and we will take more buoyant force acting on the body.
It will rise up.
It will rise up but not completely.
Ma'am, means it floats.
It will partially immersed because weight is present, no, so it can't rise completely. Weight is present, so due to the weight at least a little part of the body will be inside.
Ma'am, but the buoyancy force is great right now.
Buoyant force is more but it's not infinite, no.
Yes, ma'am.
Okay, so this is how body will be. It is partially inside and partially outside. So what is the position of body here? It is partially immersed.
Yes, ma'am.
Partially immersed and it is floating. Here also it is floating, but in first case it is sinking. Here floating but completely immersed. Third case floating but partially immersed. Why this is happening? Why it is not completely on the surface? It depends, Gautam. For suppose if you take a feather, or if you take a leaf, very much less weight, no, in that case they will completely float on the surface.
Okay, ma'am.
It depends on the amount of weight also. This is a general case, but when you take more amount of buoyancy force or very much less weight for the body, then it will completely float on the fluid.
Okay, ma'am.
General case, partially immersed. So what happens here? Weight of the body is less than buoyant force, and also density of the body is less than density of the fluid.
Yes,
Clear?
ma'am. Yes, ma'am.
So body sink in the sense weight is more.
Yeah,
Body
ma'am.
floating means two cases. Maybe weight buoyant force equal, or maybe weight is less, buoyant force is more. In this
More.
floating again you have two cases: completely immersed case, partially immersed case. Partially immersed means weight of the body is less. Completely immersed, not at the bottom, means weight is equal to buoyant force.
Yes, ma'am.
Is this clear?
Yes, ma'am.
Any doubt in this?
No, ma'am.
So you need to remember this density relations also. Weight of the body more means density of the body is more. Weight buoyant force equal means body density, fluid density equal. Clear?
Yeah, ma'am.
Very, 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 very important. Okay. Now I will send you screenshot. I'll send you the questions of this chapter which are present at backside. You open your WhatsApp.
Yeah, ma'am.
I'll send you the I'll send you the pics.
Yeah, ma'am.
Just give me a second. I'm sending you the pics. Start understanding the questions, Gautam.
Yeah, ma'am. 1 minute. Yeah, ma'am. First question, ma'am. Ma'am?
Yeah, just a minute.
Okay, ma'am.
So read out the first question, Gautam.
Ma'am, the SI unit of thrust, ma'am. What is SI unit of thrust?
SI unit of thrust. I have sent you some questions. See, Gautam, your book is different, my book is different. That was second question. Open the next image.
Ma'am, means the first question came to second image, no?
Open that
Uh,
second image.
1 minute, ma'am. 1 minute.
Mm.
Yeah, ma'am. Which of the following properties are true of liquids? Chips. Which of the following are properties of liquids?
What are the properties of liquids? They have very loosely packed molecules. They have very less force of attraction. They are incompressible and they have fluidity. They take the shape of the container. They don't have definite shape, but they have definite volume. All these are the properties, right? Now go
Yes,
through the
ma'am.
first one. Liquids have a definite volume. Is this true or not?
Yeah, ma'am.
This is true. Go through the second one. Molecules cannot move over one another.
Ma'am, one doubt, ma'am. But it doesn't. But it takes the container shape of the container.
Shape is not definite, but volume is definite. No, you take square shaped bottle, you take curved shaped bottle, whatever you take. For suppose I take 1 liter, whichever is the shape of the bottle, volume is same. No, 1 liter, 1 liter, only shape is different.
Yeah, ma'am. It
So
does not change.
yeah,
Okay, ma'am.
volume is definite, shape is
Oh,
indefinite.
yes, ma'am.
Volume is definite.
The shape is important.
Yeah, shape is not definite.
Yeah, ma'am.
That's why it takes the shape of the container.
Yeah, ma'am. Second, molecules cannot move one another. It can move, ma'am. It
Yeah,
is
it
one.
can move. Molecules will move from one place to another place. So this
Yeah,
is
ma'am.
false. Now third statement.
It exerts downward force and upward.
Third point.
Oh, sorry, ma'am. Have a definite shape.
Do they have definite shape?
No, ma'am.
They take the shape of the container. So this is false.
Container in which that? Yes, ma'am.
Fourth one.
Exerts downward and upward pressure.
So I told you yesterday class, when you take a specific point, the pressure of the liquid will be in all directions, upward, downward, sidewards, all the directions. So this is also true.
Ma'am, but they did not give a specific point right now.
It exerts downward, upward pressure. Will it exert pressure in downward direction or not? Yes. Upward direction or not? Yes. So this is true.
Ma'am, but the point which you told, it comes for all the directions.
It comes in all directions, but in the question they have mentioned only two directions.
Okay, ma'am.
They did not say only in downward, only in upward. No. They just have
Yes.
mentioned in downward and upward direction. Yes, it is true, but they did not say only. Only means wrong.
Okay, ma'am.
Okay. Now they have shape of the container. True or false?
Yeah, ma'am. True. One, three, four. Sorry, one, four,
1,
four, five.
1, 4, 5. It is given in option A. So
Yeah.
option A is the answer for first question. Okay. Now
Yes, ma'am.
see the next
Second.
question.
What is the SI unit of thrust, ma'am?
What is thrust basically? First of all, is it force or is it pressure or what? Thrust means what?
It is perpendicular force.
Yeah, perpendicular force. So thrust also will have the same units like force, right? So
Yeah,
SI
ma'am.
unit is Newton, CGS unit is Dyne, and when you take the gravitational units, it is kilogram weight in SI system, gram weight in CGS system. So these are all the different units. So what was given? Option A correct, option B correct. And if you take F is equals to m into a formula, mass is
This,
kilogram, acceleration is meter per second square. So this is also the unit.
yeah, ma'am.
So what is the answer now? Option D. All of these is the answer.
Yeah, ma'am.
Okay. Now see the third question.
Yeah, ma'am. Uh, Dyne by centimeter square is the unit of
Dyne is actually the unit of which physical quantity?
pressure, force, ma'am.
Force. Centimeter square is the unit of which physical quantity?
Area, ma'am.
Area. So force by area is nothing but what?
Mass, ma'am.
Huh? Force act
Pressure.
force acting on an unit area, Gautam.
Okay. Oh, pressure. Yes, ma'am.
F by A is pressure. F by which A? Capital A, not small a. F by small a. Acceleration is mass. Here force by area, no.
Ah, yes, ma'am. Yes,
For,
ma'am.
force by acceleration is small a. Area is capital A. Sounding wise AA, but don't confuse. Force by area
Okay.
is pressure. So what is the answer now? This is unit of which unit? Which physical quantity?
Pressure, ma'am.
Pressure. So answer is what? Option B.
Ma'am, for confusing, they gave force also.
That's why I'm telling you the concept. Dyne is a unit of force, centimeter is a unit of area. So force by area represents pressure. That's why option B.
Yeah, ma'am.
Okay. Any doubt in these three questions?
No, no doubt, ma'am.
Now go through the fourth question.
Yeah, the pair of physical quantities having the same unit.
The pair of physical quantities having the same unit. So thrust is force, pressure is different. So both will not have same units. Force, pressure, two different. So they will not have same. Thrust, weight. Thrust is also a kind of force. Weight is also a kind of force. So both are kind of forces. So they will have the same units.
Yes, ma'am.
So answer is option C. If there is any doubt, let me know, Gautam.
Ma'am, what is a unit, ma'am? I can tell.
What is thrust actually? Thrust
Force,
is
ma'am.
to force. So if it is a force, what will be its units? Newtons.
Newton.
What is weight? Weight is nothing but m into g. Nothing but it is also a kind of force.
Yes, ma'am.
So its unit is also Newton.
Yeah, ma'am. Newton. Newton.
So
Okay,
thrust
ma'am.
is also a kind of force. Weight is also a kind of force. Force. So both will have the same units.
Okay, ma'am.
Now see the fifth point. Read it out.
Uh, 1 kg weight
Fifth
by,
question.
oh, sorry, ma'am. Liquid can exert
Hmm.
downward pressure, upward pressure, lateral pressure,
So what is the answer?
all the above. Ma'am, lateral pressure
Lateral
means,
pressure means sides.
yeah, ma'am. All the above.
Lateral means sidewise. We have studied in reflection, no?
Yeah.
Lateral inversion. Left becomes right, right becomes left. Sides becomes ulta.
Yes, ma'am.
So lateral means sides.
Yeah, ma'am. It's true, ma'am. All the above.
Option D. Now go through the sixth one.
Sixth one. 1 kg weight by meter square is equal to dash by diameter.
1 kg weight by meter square. See, kilogram weight is actually the gravitational unit of force.
Yeah, ma'am.
And 1 kilogram weight, Gautam, it is equal to 9.8 newtons.
Yeah, ma'am.
Okay. And what we have to do? We have to change the numerator into dynes and denominator into centimeter square, right?
Yeah, ma'am.
So first do the conversions for numerator. 1 kilogram weight is 9.8 newtons and 1 newton is how many dynes?
10 power 5, ma'am.
10 power 5 dynes. Let this be 1 numerator. Now denominator meter square. 1 meter is equals to 100 centimeters. Now if you take 1 meter into 1 meter, then it becomes 1 meter square. So how much you will get? 100 into 100 centimeter square. So this is 10 power 4 centimeter square. 1 meter square is equals to 10
How
power
how 10 power 4 once again? Can tell.
100. You can write it as 10 square, no?
Yeah, ma'am.
1 meter is equals to how many centimeters?
Oh, 1 meter 100, ma'am.
100 centimeters. Denominator here in the question, how many meters do we have? Meter square.
Yeah, ma'am.
So meter square. 1 meter is 100 centimeters. Square is there. So square it. What will you get? 100 into 100.
Yeah,
100
ma'am.
means 10 power 2. One more 100 means 10 power 2. Total how much? 10 power 4.
Yes, ma'am.
Got this point?
Yeah, ma'am.
Any doubt?
No, ma'am.
Okay. Now substitute. So numerator 1 kilogram weight in dynes how much? 9.8 into 10 power 5. Denominator meter square in centimeter square how much? 10 power 4. So what happens here?
980.
10 power 4, 10 power 4 cancel. So numerator we have 10 power 1. Now 9.8, can I write it as 98 by 10
Yeah, ma'am.
into 10? Now this 10 also cancels. So how much will you get? 98 dyne per centimeter square.
Yeah, ma'am.
Simple, you just have to convert them into CGS system.
Yeah.
Any doubt in this? So what is the answer for this question?
See,
It
ma'am.
is option C. Okay. Now go through the next question.
Next question. 1 minute, ma'am. Yeah, ma'am. Uh,
Which of
which
the
of the following is scalar quantity?
mm,
Pressure, ma'am.
pressure? So answer is what? Option A. Go through the eighth question.
Yes, ma'am. Why does sharp knife enables us to cut objects, cut through thing more easily?
Okay. So when you take sharp knife, this is the knife. When you take sharp knife, what about its area? Area is less, right?
Yes, ma'am.
Here,
So more force.
yeah, pressure is not more force, more pressure. So pressure is inversely proportional to area.
Yeah, pressure. Sorry, ma'am. Pressure.
If area is less, force will also be less, Gautam.
Uh, area is less, force would be less. Yeah, ma'am. Sorry, pressure, ma'am. Pressure.
P is equals to F by A. F is equals to P into A. Force is directly proportional to area. That is what we have studied in mechanical advantage. No, area more, force more.
Yeah, ma'am.
Force and area directly proportional. Here, pressure is inversely proportional.
Yeah, ma'am.
Area less, force less, but pressure is more. Okay.
Yeah, ma'am.
So pressure is inversely proportional to area. So area is less means what happens to pressure? More pressure. So
More
that's
pressure.
why it will be easy for us to cut the fruits or vegetables with a sharp knife.
Yeah,
So go
ma'am.
through the options and tell me the right answer. Go through the first option.
Ma'am, yeah, ma'am. 1 minute. The pressure exerted is lesser when the same force is used. False.
Why it is false? Because when area is less, pressure will be more because they are indirectly proportional.
Yeah, ma'am.
Mm.
Yeah, ma'am. Second option.
Mm.
The pressure exerted is greater when the same force is used.
This is correct. No, when area is less, pressure exerted is more because they are indirectly proportional. So right answer is what? Right answer is option B.
B. Yes, ma'am.
Pressure is more. Now go through the next question, ninth question.
Yeah, ma'am. A rectangular iron block is kept over a table with different faces touching the table in different cases. The block exerts.
Now this is the table. Okay. So this is the rectangular block. It is having how many sides? Four sides, right? First side, second side, third side, fourth side. Let us see the third phase of the block is kept on the table. Now what happens here? Same thrust. So obviously same thrust will be there because I told you no, thrust is a perpendicular force acting on the body, right? So if you take weight will be acting downwards and at this point we will have a thrust. So weight of the body is same though you keep different phases on the table. First time first phase on the table, next time second phase on the table, next time third phase on the table, though you change the sides of the block, same mass is there no for the block.
Yeah,
Same
ma'am.
mass is there. So what happens here? Thrust will be same,
Yeah, ma'am.
force will be same, and same pressure. Option A is wrong. Same thrust is correct, same pressure, this is wrong because when you take pressure it is F by A. F is same, but all the sides of a rectangle area is not same, no. Breadth is less, length is more.
Yeah, ma'am.
Area is not same, no. When you keep the rectangular block like this, area is different, area of contact is less here, so this time pressure will be more. When length is kept on the table, pressure is less here.
Yeah, ma'am.
Force is same, but pressure is different. Are you getting my point, Gautam?
Yeah, ma'am. Yeah, ma'am.
Pressure depends on the area, no. When you take a rectangle, all the sides are not having same area, no.
Yeah, ma'am.
Okay. So option A is wrong. Same thrust and different pressure. So this is correct. Option B is correct. Force will be same, but pressure is getting different because pressure depends on the area.
Yeah, ma'am.
So answer is what? Answer is option B. Any doubt?
No doubt, ma'am.
Okay. So tomorrow also I'll take one more class. Okay, I don't know how you will be attending the exam, Gautam. I'm worried because syllabus